Alright, this video is dealing with the properties of tangents and circumscribed angles. This is section 2 in your flipbook, bottom flap of section 2. Essential question, what are the properties of tangents and circumscribed angles? Which you have already dealt with some of the properties of tangents, so some of these will seem like it's repeating what you already know. We are going to deal with this thing called a circumscribed angle, and you'll see how that relates to tangents. So, in our first section, you can see I've written some text already for you, so it's easier for you to read my writing. Let's go ahead in this section, and hang on one second, class. I'm going to verify something real quick. Okay, we should be okay with this. Alright. I'm just looking to see if I have some other notes I was going to share with you guys. Nope, we're okay. Alright. So for the first example, let's go ahead and draw a line that is tangent to this circle. That is totally one, the wrong color. Number 2, the wrong thickness. There we go. So there is a line that is tangent. And I'm going to go ahead and draw another line segment here, class. I'm going to draw a radius to this line. And let's go ahead and draw a point here because I want to let you know this is a tangent line. Let's go ahead and put some arrows on it. So this is actually a line that travels in both directions. And let's label some of these points. This is point B. Let's put another point on this line, so we can call this line AB. And we will name the center of this circle letter C. Alright, last thing I'm going to do is, let's change this to a dashed line. Okay, so we can see a difference between that and the other line. Alright. So here is our text. If line AB is tangent to circle C and CB is a radius, the angle CBA must be a right angle. Let's underline it. This must be a right angle. Now I think we've covered this right angle property. You've seen it before, but you probably don't know that it always has to be that way. Okay? So if line AB is tangent to the circle and CB is a radius, that means that the radius is touching this point B here, which, class, is called the point of tangency. If this radius CB is touching the very same point that this line AB is tangent to the circle at, then we know, let's put this in a different color, we know this angle right here must be a right angle. Alright, that's a property that you can apply a number of different ways. You saw it on one of your worksheets. We had a right triangle that was formed by a tangent line. Okay, let's take a look at how this property shows up. So in the next example, we're going to go ahead and draw some more lines. Let's draw a tangent line right here. There's a line, we'll make that tangent to the circle. Let's go ahead and draw another line segment. Let's put it about right here. Hang on a sec. See if this is going to make sense to us. Okay, that makes sense. And then let's go ahead and draw, let's put the point of tangency on here first. And then let's go ahead and draw a line segment from the center of the circle to that point of tangency. And I'm going to make that a dash line again, just so we can see that that is a different kind of line. That's the radius. So I think that's good. Let's move this point of tangency over a little bit so it makes sense. It's hitting our circle right at that point. Okay, let's label some of these parts. I'm going to label this as point B. Let's label this as C. Let's label our center of our circle A. And let's see, let's put some arrows on our tangent line. Don't need that, but just to show you this is representing a line. Okay, now you can prove whether a line is tangent or not by using the Pythagorean theorem. So let's say your question was, is line CB tangent to circle A? And the answer would be this. If you can prove that triangle ABC is a right triangle, then you've proven that this is a right angle. Angle C is a right angle, and therefore you've proven that line CB is tangent to circle A. So I'm not going to label this as a right angle because that's what you're proving. So let's just go ahead and label these so we can match them up with our Pythagorean theorem. Let's say that we're going to call this line segment, this side of our triangle A. Let's name this as B. Let's be careful, class. This C is the whole thing. So I'm going to go ahead and show you that C is the hypotenuse. So let's go ahead and draw this here. Remember, we've seen this before. When you see a line like this, and then somewhere inside of that line, you've got a number or a letter. In this case, we're going to label it C. This means the whole hypotenuse. In some of your other diagrams, I label the radius as a separate section and then the outside part of this line segment as a separate measurement. But in this case, we're looking at all of C. So, if a squared plus b squared plus c squared, if a squared plus b squared equals c squared, then CB is a tangent because we know this angle is a right angle. But the opposite is also true. If a squared plus b squared, if you check this out and it does not equal c squared, then CB, you have proven that line CB is not tangent to circle A. So you can use Pythagorean theorem to prove whether a line is tangent to a circle or it is not tangent to a circle. Okay, last property we're going to learn regarding tangents. Let's go ahead and draw a couple more line segments. Let's draw tangents to this particular circle. So here are two tangents to this particular circle. Let's go ahead and label the points of tangency right here so we know they are tangent. And then let's go ahead and draw two more line segments. These are actually radius. Plural of radius is radii. You'll see that actually in your worksheet coming up. Let's change this to a dashed line, and we'll do this as a dashed line as well. Alright, and let's go ahead and label some parts of this. Let's label this point out here as A, and then let's label this point B. We'll label our center of our circle C, and then this point of tangency is D. And then let's label some of our angles. So let's just call, let's see, let me fix that D. Let's call this angle as angle 1. Let's call this angle at angle A as angle 2. In class, we're going to assume that AB, let's make these rays, so they only travel one direction. Let's assume these two rays are tangent to circle B. We see that because of those points, so that means I know that these are going to be right angles. If they're tangent, that means they make right angles to the radius of the circle that is going through the same points of tangency. So we got two right angles, and we've got an outside angle, and we've got a central angle. Here is our property. Quadrilateral ABCD. Remember, a quadrilateral has four sides. So quadrilateral ABCD kind of looks like a kite. Is formed by two rays tangent to circle C. We've already talked about that. They're tangent at point B and tangent at point D. And a central angle that is formed by the points of tangency. So you can see angle 1 is a central angle, and it is made by this radius, which is perpendicular or right angle to this ray AB, and this radius is also at a right angle to ray AD. So here's the property that's interesting. Since the angles of a quadrilateral always add up to 360 degrees, now class, you know the angles of a triangle add up to 180. You should remember from last year that the angles of a quadrilateral add up to 360. Since we know that's true, and we know that angle CBA and angle CDA, those are right angles. Think about it. If those are both right angles, 90 plus 90 is 180. That means if all of our angles of our quadrilateral add up to 360 and B and D add up to 180, then there's only 180 degrees left to distribute between the circles, and that way we know. That means we know that the measure of angle 1, this central angle, and the measure of angle 2, this outside angle, must be supplementary, or they must add up to 180 degrees. So if you see this drawing, two tangent lines or two tangents to a circle, and then you see that we draw two radius or radii that touch at the points of tangency, and we know that when we do that, look at our first example, we know those are right angles, therefore we know that 1 and 2 are supplementary. Now the last thing I want you to label here is, let's define this, because we talked about circumscribed angles in our essential question. Angle 1 is called a circumscribed angle. So up here, maybe you can fit this in your video. Angle 1 is called a circumscribed angle. And let's label it so we know it's just this one. Oops, let's make that a little bigger, better. It's just this angle, not any other angle 1s that you've listed. So a circumscribed angle, actually, class, is an angle that is formed by two tangent lines, and it's the radius that actually form that new central angle. So that is called a circumscribed angle. Okay, that is the end of this video on tangents and circumscribed angles.